This is a movie about plotting straight lines on a graph and then using them to shade out areas on the graph according to the equations of the lines. So previously you've encountered the equations of straight lines in the form y equals mx plus c, where y is the subject. And it's easy to plot the line because you always know that the x is the gradient, so the number, it goes up or down every time it goes one forwards. And c is the y-axis intercept, where it crosses the y-axis. So as two examples of that, y equals 2x plus 1 would cross the y-axis at plus 1 here, and every time it goes one forwards it would go up by 2. So 1 forwards, up 2, 1 forwards, up 2. Once I've plotted a few points, I can put the ruler on and draw the line. Same thing here, it's going to cross the y-axis at plus 1, and every time I go one square forwards, I'm going to go down by a half. So 1 forwards, down a half, 1 forwards, down a half. It looks as though I've been a bit inaccurate with my ruler here, but it should go through these points here, and that's y equals minus a half x plus 1. Now what changes in this topic is that the equation of the line is quite often given to you in a different format. Instead of giving it to you already nicely arranged like this with the y on its own, it might be given to you like this, with the x's and the y's together on one side equals a number on the other side. Now, it would be possible to rearrange this, make y the subject, and plot the line in exactly the same way as before. But another way that you can do this is by finding where this line crosses the two axes and then just joining the points up. So if we start by thinking about the y-axis intercept, now anywhere on the y-axis, you can see here these points on the y-axis, 0, 0, 0, 1, 0, 2, and so on. Anywhere that's on the y-axis is going to have an x value of 0, no matter what the y value is. So if I want to find out where it crosses the y-axis, I can put x is 0 into the equation. So if I take that equation and put x is 0, 2 times 0 plus 3 times whatever the y must be, must give me 12. So by solving that equation, I can tell that the y value must be 4 when the x value is 0. So 0, 1, 2, 3, 4. I know that that line must cross the y-axis there. Now I do the same to find out where it crosses the x-axis. So when it crosses the x-axis, no matter what the x value is, the y value must be 0, otherwise it's not on the x-axis. So if I know that the y value is 0, I can put that into the equation and then work back to find out what the x value must be. So 2 times the x value plus 3 zeros must equal 12, so x must be 6. So I plot that point where x is 6. So x is 6, it's there. So now I know that this line goes through that point and that point, so all I need to do is join them up. Now you've got another couple of lines here as well. So here we've got 5x plus 3y equals 15. So when it crosses the x-axis, I know that the y will be 0. Put y is 0 into the equation, and I find that x must be 3. So when this line crosses the x-axis, it does so here where x is 3. If I want to find where it crosses the y-axis, I put x is 0. So going back to the equation, putting x is 0 tells me that 5 lots of 0 plus 3y is 15, so y is 5. So it's going to cross the y-axis at 5. So I've got the 2 points on the line, and all I need to do is join them up. Third example here, 3x minus 6y equals 18. So when it crosses the x-axis, y is 0. So solve that equation. 3x minus 6 times 0 is 18, so x is 6. So it crosses the x-axis when x is 6 here. When it crosses the y-axis, x is 0, so that means minus 6y equals 18. So y equals 18 divided by minus 6, which is minus 3. So it crosses the y-axis down there, and there is my line. So now we know how to plot the lines. What we need to know next is how to find the areas. These questions are not going to give you a problem like plot that line. They're going to say shade an area where 4x plus 3y is equal to 12. Now it's important to understand that the line 4x plus 3y is equal to 12 divides the graph into 3 regions. Anywhere along that line, 4 times the x value at this point plus 3 times the y value at this point will equal 12, because that's the rule of the line. So that's one region, an infinitely thin space along that line. And then the other 2 regions are the other 2 sides of it. And on one side of them, the equation will give me an answer that's greater than 12. On the other side, the equation will give me an answer that's less than 12. All you've got to do is figure out which side is which side is going to give you greater than 12, which side is going to give you less than 12. So to go back to the beginning, the first thing I do is plot the line where 4x plus 3y is equal to 12, and I do that the same way as before. And I've done my working up here, so it's going to cross at x is 3 and at y is 4. X is 3, y is 4. That's how I found my line. Now, to find out which side is going to have 4x plus 3y greater than 12 and which side is going to have 4x plus 3y less than 12, I test a point. Now, it is important that you do this because sometimes the examiner arranges it to be a little bit less obvious than it appears. So I've chosen any point at random. I've chosen this point here, which is x is 1, y is 2. I'm going to put that into my equation, 4x plus 3y, so that's 4 times 1 plus 3 times 2. 4x plus 3y at this point then would give me a value of 10. 10 is less than 12, so this is the side of the equation where 4x plus 3y must be less than 12. And this is the side of the line where 4x plus 3y must be greater than 12. So I figured out which side is which, and I can shade out the side that I don't want. So in this question, it's asked me to shade, to find the region where x is greater than 0. So I can shade everything on this side of the y-axis, because that's where x is less than 0, so I don't want it. It's asked me to shade, or to find, where y is greater than 0. So I shade out everything where y is less than 0, which is below the x-axis here. So that's now left me with this quadrant. And finally, it's asked me to show the region where 4x plus 3y is less than 12. Well, I know that's on this side of the diagonal line, so I shade out everything on the other side that I don't want. My final answer should be this triangle here, which is the region of the diagram that obeys all 3 of these inequalities.